This is 5-2, by the way. The way that I factor.
We have stuff better on our desks.
Yeah, please go right ahead.
Why do we need
help
off our desk for that?
Yeah, you had more space, and I love scaring you guys. It's great. Yeah, you can keep it. Now, the way that I do the factoring
Teacher.
is I know that there's multiple ways of doing this, and I know that a lot of you guys have seen, box methods, guess and checks, and all that kind of stuff. The way that I set up my factoring problems is that I normally always use one of those T-charts. Yes, sir.
Yep.
I don't. Do you have a paper cut?
I don't know
Did I
what it
scare you to
is,
get a paper cut?
but when I write like this, and it stings because I rub my hands together and the friction stings.
You can use your left hand. Use your left hand.
All right.
Or here, how about here? I got masking tape.
No. Definitely not.
I have a stapler.
Sound like the intern trainers.
Dude, I'm
Oh
telling
wait,
you.
I do have a Band-Aid. You do?
I was like, you are my Lord and Savior, Mr. Bro.
Let you just strike you down,
Thank
boy.
you so much.
It will work. Once again, so here's how I set these things up. Ladies and gentlemen, I want to do a bunch of these here today. Remember, what I'm looking for here are the multiples, what times what is 28, that I add together to get negative 12. So what are my factors of 28 that gives me a sum of negative 12? I'm talking about factors and sums. That's where the times table test comes into play. The quicker you're able to remember what times what is, put your feet down. That's a weird way to put it. What times what is negative 28. If you're able to identify those a little bit faster, then you might find the sums quicker. So think about it. What times what's negative 28? Add together again.
Negative 14 and 2.
Negative 14 and 2. 4 and 7 is right. 4 and 7. If I multiply those around, notice how I have to get a negative 28 and I add it to get a negative 12. That means one number is negative, one number is positive. Do you agree? Now, in order to get the sum equal to negative, that means the larger of the two numbers would have to be negative when you're adding together. So if I did that, I'd have negative 7 and positive 4 will only be negative 3. That won't work. So I go back to 2 and 14. 2 times negative 14 gives you negative 28. 2 plus negative 14 gives you negative 12. So when you go to factor this out, those are your terms. X plus 2, x minus 14. Okay? You've done this many times. This is one of those, once again, those reoccurring themes all throughout math. You will factor again next year. We factor again later this year as well. We factor with trig stuff. There's a lot of stuff we do with factoring. What's that? Then we do a little thing called factor by grouping. I'll probably only do like one of those today. I don't think we're going to get into too much of it because it's Friday. I know you went through all the homework anyway, so we'll just give you a little bit of the easy stuff today. All right? So, again, same idea. What times what is negative 21. That adds together gives me a positive 4.
Let me check my charts. 7 and
Negative
7.
7 and negative 3. Good. So, yes, ma'am? Yes, ma'am? So when you factor that out, you're left with the terms x plus 7, x minus 3. And that's the factored form. Oh, it is?
Yeah. We just have to her face back.
Is it really? Or you're just making that up? We should sing to her.
When she walks in, let's sing.
We'll do that.
Whose birthday is it?
Stacy.
Oh.
Whose day is
In
it?
case you guys are wondering, my birthday's on Valentine's Day. In case you were wondering.
So is my son.
That's great. Okay, I see.
My
I have the
birthday's
same birthday as
February
you.
16th, except for also on February 14th,
Yes, it is.
Michael, happy birthday, man. Thanks, Willis. It's your birthday.
Yeah. Just
Boy, I'm back. It's not your birthday.
Ladies, this is why I should not have done the times table test. Once I do the times table test, it's all up for grabs. I can see this now. You guys are you're trying to use humor to the fact that you all lost.
Hey,
Not in here, please.
what are you doing? It's the belt loop, all right, Mike? Mistakes happen.
What times what is positive 28? You add to get negative 11.
That teacher walks in and she's like, weird.
Let me ask you this. What changes if I do that? Do you remember? You're what? What am I finding, Soda? Is the answer on your phone?
Everything turns into
Come
zero.
on, birthday boy, what you doing? Done. Here it is.
Wait, are we?
Happy birthday to you. Happy birthday to you. Happy birthday, dear Michael.
What?
Happy birthday to you. You're not embarrassed, are you? Anyway.
License?
No. What happens now?
We have to like it.
Error 5 on that one. All right. I only have we only have a little bit more of this to go through. I don't want to push too much on a Friday because I can tell pretty much it's lost cause at this point.
Yeah.
Remember, the only thing that changes now when you see equals 0 is that you're solving for the zeros then. Once you factor it out, you're doing what you kind of did yesterday when you graphed that. What are your zeros? What's that? For what? Zeros? When you have to solve for zeros, what you're doing is you're setting each one of these equals 0. 4, 7. What times what is positive 28 to give you negative 11? Negative 4, negative 7.
So would it be 5
For your x symmetry. Okay. So remember, the things that changes of this stuff is that we just take it that little step further every once in a while. We set things equal to 0 to find the actual intercepts. The way that factoring works doesn't change. The factoring works the same. The only thing that's different is when you see equals 0, that means you have to tell me what the zeros are when you're done factoring. This is a more common approach. Most of our problems are going to have the equal sign in it, so you're going to have to find zeros. Very similar to what you guys did yesterday with your graphing.
Should we try these? Okay. Oh, okay.
Now there's no b term, is there? Just x squared minus 1.
Plus
Is it 1?
x equals minus 1.
It's negative 1.
No. Let me ask you this. This is a special pattern. This is called a difference of squares. Here's what happens. Is the first term, is the x squared, a perfect square?
Yes.
Yeah.
Is 1 a perfect square?
Yes.
Yes. Is that a subtraction symbol?
Yes.
If you can answer yes to all three things, then when you factor this, what's the square root of x squared? What's the square root of y then? And you alternate signs.
Why does it be a
Because there's nothing called the difference of, or excuse me, the square of sums. There's only difference of squares, there's no sum of squares. It only works. And here's the reason why this works. If you have x squared minus 1 and you set it equal to 0 to find zeros, one method to solve this problem is to add 1 and then take the square root. Whenever you take a square root over an equal sign, you have to do plus minus. I'm just saying this is why this works. So what happens is square root of x squared is x, square root of 1 is plus 4 minus 1. So my zeros here are negative 1 or positive 1. When you have it, what's called a difference of squares, that's how it works. I'll show you another example here in a second. Yes, ma'am? Yes, it has to be a subtraction symbol. For example, let's say you have x squared minus 25. Is x squared a perfect square?
Yeah.
Is 25 a perfect square?
Yeah.
Is that a subtraction symbol?
Yes.
So you get x plus 5, x minus 5 when you factor that. Oops, let me do that out.
It's addition. Can you just do x plus 5, x plus 5?
No, this only works for subtraction. Once again, the reason why this does not work for addition, if it was x plus 5, x plus 5, when you FOIL that, remember good old-fashioned Billy binomial?
No.
No? You do. You remember Billy binomial? First,
I remember Billy Bob.
outside, inside, last.
Guys, that spells out wrong.
Billy binomial.
That's the devil child.
Hey, Willis, what are you doing?
Hey, Katie.
Okay.
What happens is you wind up with a middle term when it's plus plus. If it was x squared plus 25, if it was just x squared plus 1, if it was x squared plus 25 equals 0, and I wanted to factor that or solve that, what happens is you have x squared then equals a negative 25. Can you take a square root of a negative number? Not until section 5.5.
Is that when you get I?
That's when you get imaginary. X squared minus 49. Again?
Not again. The first time.
Is x squared a perfect square?
Yes.
Is 49 a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
What are your terms?
Yes.
X plus 7, x minus 7. Now, just to mess with you, because I like to scare you a lot,
Wait, we don't have to tax scores.
Whoa.
this is where we are heading. I do not believe that we'll do this one tonight. I'm going to give you a couple of them. I'm not going to completely show you a ton yet. When you have to solve the equation with a leading term coefficient that is not equal to 1, factoring takes a minute longer. So, I'm stressing.
I know.
Once again, so what happens here is you do the following pattern. 3 times 5 is how much?
15.
What times what is 15 that I add together to get negative 8?
7 and 8.
7 times 8 is 56. Wrong. What times what is 15?
3.
Negative 5 and negative 3. What I'm doing here is, there's 2 ways that this is called. This is called factored by grouping, or this is called split middle term. Depending upon who you had for algebra, what school you're at for algebra, you might have heard different things. In this case here, I do this. 3x squared minus 3x minus 5x plus 5 is 0. Do you see how I have negative 3x minus 5x? Doesn't that equal negative 8x? What I'm doing here is I'm taking my trinomial, my 3-termed figure, and I'm turning it into 4 terms. Because now I can group 2 and 2. I'm grouping to find GCFs. What's the greatest common factor there? 3x. If I factor out a 3x, what am I left with in the inside? Once you get the GCF and you have your first term, x minus 1, you want that second group of numbers, that negative 5x plus 5, to wind up with the term being x minus 1 inside there. So what's the GCF of negative 5 and 5?
5.
Fine, but what do I want to take out though? I want to take the negative out. The reason is, once I divide out by the negative, this second term becomes positive, or excuse me, becomes negative. 5 divided by negative 5 is negative 1. This is how you factor problems that have a leading term coefficient not equal to 1. You are factoring by grouping. Split middle term, however you want to call it. So, are these two terms the same? X minus 1 and x minus 1?
Yeah.
Write it down. What are you left with?
3x and 5.
Oh man.
And that's all it is. What you're doing here is you're factoring, it's called factoring by grouping. Some people call it split middle term. Take the first, multiply it by the last, and group them. Now, there's one last step here because it says equal to 0. What are your zeros then? 1 and, is it negative 5 over 3 or positive 5 over 3? It's positive 5 over 3. Add 5 divided by 3. Okay? So tonight, I have a couple of these for you to look at. It's in 5.2.
Blessed be the Lord. You do not want to give us homework.
Why would you give us homework?
Willis, you're the best. No, not doing that.
5.2 starts on page 260. It's a section 5.2. And I want you to do 24 through 34.
Ow. But
Evens,
Okay.
Even.
36 and 40.
Why would 36 and 40?
It's two problems with leading term coefficient not equal to 1.